Hi everyone, welcome into the Millstone Makers podcast, where we take a closer look at food process, supply chain, and financing. In each episode, we analyze ways companies are making food happen across the company and across the world. And just like that, we are back again, better and brighter. I'm Thomas Smith, and before we get into today's episode or begin discussions surrounding food manufacturing, I wanted to give you a recap. Last week, I laid out the purpose of the podcast. In each segment, we go ahead and analyze ways companies are making food happen through food process, supply chain, and financing. We observe ways that companies help to satisfy food regulation, combine science, select machines, select team members within facilities, and help position those people and products to help make their food safe, make it tasty, and also to make it profitable. In each episode, we also do a follow-up discussion on a particular process that companies use and how it provides value to us as food consumers. We'll have some social media highlights. We'll have opportunities for people to engage in discussion. And then we'd love to be able to hear your thoughts on the topics and the problem-solving techniques that people are using on a day-to-day basis in management. Soon we're going to have some case studies, and that'll enable you to begin thinking about people in the industry and open up this to be a broader group conversation online. And with that information, I'd like to welcome you to episode 2 of the Millstone Makers podcast. Today is July 25th, 2019, and on behalf of our team, I'd like to thank you for tuning in. Today, we're going to take a closer look at high-pressure processing, whereby food companies have this equipment that is not only growing at a huge rate, but it's also predicted to be worth over $500 million in just the next 3 years. It's absolutely absurd. And this episode is going to be part 1 of 4 of our non-thermal processing series. We hope that you're able to tune in to the future episodes of this series. And if you missed the prior episode where we introduced the podcast, feel free to check it out. It'll be on all of our channels on iTunes, Spotify, SoundCloud, and a couple others that I'll have links to in our descriptions. And as I mentioned each time at the beginning here, the Millstone Makers podcast is purposed to give a deeper analysis of operations. And those operations don't just involve raw materials and food products. They involve teamwork. They involve being able to have and envision a final product in mind that either other businesses or individual consumers can eat from the comfort of their home, on the road, in the sky, or even at work. And so for every product that we see in stores and that we see online, there is a process that's involved. There's regulations that surround what's able to go into those fast food franchises for food. There's a blend of business and science folks that are working together as teams. There's inputs, process, logistics, machinery, capital budgeting, risks, fraud protection, quality control considerations, sanitary requirements, marketing. There's risks, and of course there's rewards. And so while there's so much to unpack, I'm here to help provide the opening statement to conversation. And my hope is that to all of our listeners, that we give you some detailed thoughts on a process every week that is used to produce food. But then we relate it back to some of the macro trends that are happening in the food world, as well as the micro strategies that established companies are using to make food happen. And so today we'll be focusing on one particular process. It's known as HPP. HPP is used by a lot of companies that are already well established in-house. And then it's also used in the contract manufacturing service realm. So there are companies that they don't actually produce food. They don't actually have raw materials that they're using. They simply provide the HPP processing. They charge a tolling fee, a small amount, and then that other external food company is able to have HPP processing done to their own food products. But some of the well-known companies that are doing this very well are Hormel Food, Cargill, Suja Life, Tyson Foods, Universal Pasteurization, Motivated, and Aver Technology. And alongside those large companies, there's a lot of value in it. Right now, the market value is about $500 million, and that's predicted to mature over the next 3 years as we get closer to 2022. I think the compounded annual growth rate is something like 12%, 11 to 12%. So there's a lot of potential that is going to happen with HPP processing, and it'll be very exciting to see how companies use it for their own applications. And so before we analyze and think about how companies are using this product, using this process and products, and where you can find some of those products, let's take a step back and discuss what HPP actually is. HPP is not a new process, but it has definitely gotten some upgrades in the last couple of years. So HPP, as I mentioned, is short for high pressure processing, and it's a process that is applied to already prepackaged products. So it's not like a company will receive raw ground beef and apply it in the factory and then prepare to ship it. It's something that is applied to ground beef that's already been packaged and then is sent off to a facility or to a part of the company's locations into the vessel to be HPP'd. It's a type of pasteurization, but there's no heating involved. And so it becomes this really fun game, but also a very a game that requires some due diligence, because the key is all about applying the right pressure at the right temperature for the right amount of time. And so food, usually for the majority of companies, it gets shipped from the manufacturer to a company like Avier, who has their main focus on HPP, and it gets shipped to one of their locations. I'm pretty sure, for example, there's one in Dallas. I believe there's one around the Los Angeles area, and there's one around the New York or Chicago area. But the food will get shipped to that HPP contractor, and then they set it up and place it within these machines. And I'll include some photos of these machines in the description of publicizing this podcast. But these machines are massive. We're talking multiple feet wide, multiple feet high, and they can either be set up vertical or they can be set up horizontal. And so the food is placed inside of a chamber, and then it's subjected to really, really intense pressure. To be more specific, it's subjected to hydrostatic pressure, and it's a treatment that we'll talk a little bit more later on in the podcast, but it offers the food industry another level of food safety, because HPP is just as good as heat pasteurization, but it also meets the consumer's demand for fresher tasting food that's been processed less. And so generally processing foods with heat can lower quality, and then it's also noticeable by consumers. But it's up until about a decade ago, it was really the main and just dominating form of pasteurization, and probably for the future it still will be. But this notion of HPP will begin to change that conversation. Another really cool aspect about HPP is that it doesn't affect taste. It doesn't affect smell. It doesn't affect the visual properties of food, and you're able to retain the nutritional benefits of a food. And so that is a huge provision of value. The properties like texture and hardness of a solid or viscosity of a liquid are also retained through HPP, similar to heat processing. And so you can retain the aroma, you can retain the color of a food product, and you can also reduce the activity of microbacteria, which is cool, because if you can, help to modify enzymes and modify structures while still being able to uphold the sensory quality of food, then you're able to make food safer. You're able to make food taste just as good, and the shelf life will be extended as well. So things like Listeria, Salmonella, E. coli, which is things that you see in the news pretty often, those things can be eliminated or reduced to a very, very small amount. That is a huge stepping stone for food companies. I saw in the news recently there's a company called Pita Pals, and Pita Pals had to do a recall on their hummus products because of a Listeria concern that they had last week. And so you can imagine the cost that's involved in not only locating that inventory, not only extracting that inventory and shipping it back to their facilities for R&D purposes to figure out and trace where this issue originated from. But people just, when we make food and we send it out of our facilities, the hope is that businesses, restaurants, and people at home can just really enjoy solid food. And so what's nice is that HPP processing is something that can be applied to a lot of different food groups. This is something that can be applied most notably to juices and smoothies, beverages, guacamole, salsas, purees, baby food, pet food, soups, salad dressings, even ready-to-eat and meal trays. HPP processing can be used there. The challenge becomes, what's the right way to go about it for that food group? Because each food group needs to be, should be, and by FDA regulation will be approached differently by food companies. And so HPP, while there's a lot of tech involved and a lot of marketing push for it, it comes down to a couple of scientific principles. And so we're not going to go too in depth of the thermodynamics that are involved with processing this food, but I think it would be awesome to just share some of the history of it and introduce you listeners to how this idea came about. It usually starts with a handful of people who think to themselves, there's got to be a better way of doing this. There's got to be a better way, in this case, to pasteurize food. Or there's just, they're curious about maybe finding an alternative to the existing solutions for pasteurizing food. And so there was this scientist named Percy Brigman, and he was born in the late 1800s, earned a Nobel Prize for physics in the 40s, Harvard grad, really smart guy from Massachusetts. And his thing was high pressure processing, and even in a broader sense, high pressure physics. So he was able to begin the conversation around HPP, do some test trials, and provide results that help to support HPP as a viable option. And so his hypothesis, his thesis statement was that if we can provide the right amount of pressure for the right amount of time at the right temperature to already packaged foods, then we're able to extend the shelf life of foods, which cuts down on waste. And we're also to provide people a greater sense of security to the food that they're eating on a daily basis. And so in the beginning, machines were very simplistic, not too much going on. And today, that's changed. I mean, machines have just expanded and they've grown literally, and they've also improved to help reduce error by so much. Generally, though, machine pressures will range anywhere from 20,000 to 150,000 pounds per square inch. Just think about that for a second. 20,000 to 150,000 pounds per square inch. There's no heat applied. All that's involved on the bigger picture sense is there's a pressure vessel which the food will be placed into either from the side or vertically, and then pressure is applied all around that vessel with water. And so that pressure is applied uniformly. It's also applied instantaneously, and it follows what's called the isostatic rule. And as a result, when foods go in, they've already been packaged, they've already been sealed, they've already been labeled with their best by date and their UPC codes. But as a result, there's some decrease in volume. Volume never increases after this pressure through water has been applied, and only the larger molecules inside of food are affected. And so what's nice about that is that parts of food like the enzymes, the proteins, the lipids, those can show changes. But flavors and vitamins and nutritional components are unaffected. And so every food is composed of a different blend of fats and carbs and sugars and things like that. And so you think about for every additional, I think the math works out where for every additional 4,000 pounds, because there's some heat changes involved in food, but for every 4,000 pounds of pressure more applied per square inch, temperature goes up about 1 degree Fahrenheit. So 1 degree increase for every 4,000 more pounds applied. And that change somewhat in heat is called, it's sometimes hard for me to pronounce, but adiabatic heating. And aside from that temperature change, there's also some compression involved. And that compression of the food in its packaging will depend on the group. So, for example, chicken is not going to be changed the same way tuna would, and it's not going to be changed necessarily the same way as guacamole would because of the density of that product. And so as companies are using HPP to extend shelf life, the recommendation by professionals is start with the end in mind. Always start with the end in mind. And so companies will use HPP processing for a couple of different reasons, but they'll usually justify it by either for preservation purposes, for enhancing functionality, lowering sodium levels, so health-related purposes, or it can be help the harvesting process and speed that process up. One example is how Cargill uses HPP for their minced raw beef. And so it helps with the shelf life. I don't have a number on it specifically, but I'm guessing it's a couple of days to maybe 2 to 3 weeks. And that is, on their scale, in the food service industry, millions of dollars, at least hundreds of thousands. You can also use HPP to help accelerate the diffusion of things like marinades into meats. So one of my most recent favorite foods is pre-seasoned, pre-packaged Smithfield pork links. And you can imagine that they have some proprietary way of injecting their marinades into the pork links that they use for their products in stores. But it's very possible that they use HPP to help add value. And it's cool because a common theme amongst foods that are having HPP applied to them, they're usually in flexible or partially rigid packaging. So very rarely, and it's not even recommended, people never want to use metal cans, glass bottles, or paperboard for HPP because they'll either just get crushed or cracked, or the quality doesn't work. The cycles are only 3 to 6 minutes, so it's fairly short cycle that's applied, and the pressure is usually applied continuously. Some people will do a batch application of pressure, so in pulses for products that are more pH stable and have preservatives, but for products that have a short lifespan and where freshness is of the absolute most importance, like seafood and freshly squeezed 100% juices, they are usually using continuous application for HPP. Some best practices that we've been able to read about and hear also through phone calls and online people share about is that a good recommendation for HPP is to use a well-sealed package or bottle. Another thing is being able to minimize the oxygen that surrounds the product. So for example, when you purchase orange juice from Minute Maid, or you buy pineapple juice from Dole, whether it's in a can or it's in a carton or in a plastic clear bottle, a PET bottle, usually the amount of oxygen that's in that container is very small. And that's on purpose. That's by design, because when you have oxygen inside of the container and you apply pressure, either continuous or pulsated, the amount of oxygen that's in there can affect the quality of the pressure being applied, and ultimately the end taste and shelf life extension that comes out of using that process. And so companies will decide, alongside the pressure amount and the time amount, also what temperature is good for the application. So for sometimes companies will use temperatures below 0 Fahrenheit. Other times they'll be well above 0 Fahrenheit. And while we won't go into depth, I'll include a link or two in the description that you can read more about some of the techniques that are used. But within HPP, you've got things like auto shrinking, you've got heat shrinking, and you've got wire winding. But in any case, it comes down to those three things. It comes down to the amount of pressure that it's applied, the temperature at which that pressure is applied, and then how long is the pressure applied to. It doesn't matter if the vessel that holds the product is 25 liters or 600 liters. Companies have to be able to figure out how much throughput they need to make their business profitable. And speaking of profits, the final part of this podcast that I'd like to discuss and open up conversation for is the financial considerations around HPP. So no doubt HPP is a good investment, but it's not always good for everyone. And even more so, it's not always good to start off with HPP, as it can be complicated, it can be expensive. And so really knowing the purpose of why your company or why other companies are using HPP is important. And it doesn't make sense to waste and throw money at a process that there's no ROI, there's no return on your investment. And so with machines for HPP costing sometimes upwards of $3 million, it's not always the right move. There is a wide range. Machines will range from $300,000 to $3 million, sometimes above that, based on a case-by-case basis, if there's customization that needs to happen. But finding that right capacity and that right amount of automation for your HPP machine is super important. A lot of the majority of the time, most small businesses that are creating their food products, and they're not public companies, they're not even probably medium-sized companies, they will do contractual. So they'll use somebody whose main focus is HPP processing, and that cost is usually by the pound. So it doesn't matter if it's a solid, it doesn't matter if it's a liquid, it's all just done by weight. So if you think about that in context, alongside a well-known company like Suja Juice, which is in a lot of stores nationwide, including Walmart, they offer juices that include, I think it's something like 10 fruits, 10 freshly squeezed juices, or 10 freshly squeezed fruits and a couple of vegetables in each bottle. For a 12 ounce, 12 to 16 ounce bottle of juice, it's about a nickel. It's about 5 cents, which is not bad at all if you can capitalize on the trend and charge another $1, right? So you're making 95 more cents from 95 more cents pre-distribution, pre-freight forwarding, all of those things. You're making 95 cents more because consumers are really looking for the cold press HPP process juices and are willing to pay for it more, even though it's not costing them too much up front as a manufacturer. And so speaking of those numbers, I think it's cool. Online you can usually find some more financial information without having to go through sales from HPP providers. And again, vessels, they're very large machines. Sometimes they're 30 feet long, sometimes they're only 6 feet long, but the cost is usually between $300,000 to $3 million. Usually only takes 2 to 3 employees to operate a vessel. So the labor cost is pretty low. Even the energy cost is relatively low. It's only a couple of dollars. So in the big picture, it's really just a drop in the bucket. And if you can do a couple of cycles per hour, I mentioned how a cycle can usually be 3 to 6 minutes. So if you can do about 5 to 10 cycles per hour and you're operating throughout the day, then your upfront costs at the beginning of the investment will be on the higher end. But again, the unit price that's kind of tapped on to the product itself is only usually between 5 to 10 cents. So the key, again, I always come back to what's right for your business, or what's right for, just in looking out into the world, what's right for businesses that you see using it. It doesn't matter if you're a juice company, a guacamole company, if you're a protein provider. HPP is something that can be used, and it's just something where if the numbers are right, if it's something that your target markets are looking for, It's a process that can be applied. And so with that being said, I'm glad that you have set aside time to tune into the Millstone Makers podcast. This has been fun and insightful. Next week, we'll discuss part 2 of the non-thermal processing section with a specific focus on the use of UV, ultraviolet light, to help food manufacturing as well as help serve their markets better. As a reminder, you can find the Millstone Makers podcast on social media channels. We publish to Spotify, iTunes, YouTube, SoundCloud, and many more. You can also find sound bits of this podcast on Instagram, Facebook, TikTok, as well as submit your questions to our IGTV episode that we'll provide up later tonight. I'm hoping to maybe do an IG Instagram live in regards to answering questions that you may have about this podcast, as well as discussions that can come out of this. Thanks for tuning in, and hope you have an awesome day.